Hello, my dear friend. In this series of Re-Neet examination 2026, now today we discuss one new chapter, that is electrostatic. In this electrostatic, we are discussing the two segment here. First is electric field and charges, and second is electric potential. So whatever the question is asking in the last previous year, 4 to 5 year back, in the NEET examinations, we are discussing all the concept, all important concept, mostly all concept, and then after we are discussing about the previous year question according to that segment, right? So let's go with the next slides. I am discussing the first question here, and firstly I read the question, then after we are discussing the concept, and then again we solve the question, right? The first question asks in NEET 2026. The question is, which of the following statement is correct? Means they are asking to you which of the following statement is correct here. So in this case, they are talking about the structure, or we can say that the we can say the theory of conductor. Okay, so inside the conductor, the electrostatic we can say that electrostatic field is zero. That is 100% correct statement. So first of all, we are discussing about the about conductor, because whenever we are discussing the theory, then we easily give the correct answer here. To see this theory part, right? So electrostatic property of conductor is, first of all, inside the conductor the electric field is always zero. Due to Gaussian surface, we can say that electric field is zero here. Where mobile means small charge are rearranging inside the, that will be cancelled to electric field, means electric field inside the conductor is zero. These are the property of conductor. The electric maximum current will be drawn at the outer surface of the conductor. Means here is the maximum current, electric field is maximum, here the electric field is equal to approximately zero, or we can say that zero. Very small leakage current are flowing here. Leakage, we can say that electric field will be there, that is approximately negligible, right? Whenever we are talking about the excess charge on the surface of conductor, just now I am saying to you, the excess charge will be flowing on the surface of conductor, that is E dot ds. This is the Gauss law, is equal to q in by epsilon naught. Okay, it's equal to zero, right? Now this next is the surface field and charge density, that is E is equal to, that is sigma by epsilon naught. This is the surface charge density. Okay, and next is the constant potential will be there throughout the like surface, we can say that. Now see, this is the question. The first, inside the conductor the electrostatic force is zero, that will be 100% correct. Now second is, electric field at the surface of conductor does not depend on surface charge density. So they say that does not depend. Not depend means that is wrong. That is depend on the surface charge density, right? Now in the interior of the charge conductor, okay, can have the no excess charge in the static situations. So in the inside, with that it will be also correct. That is how much E is equal to, already we can say that sigma by this formula I am discussing here, E is equal to sigma by epsilon. These are the formula here in third case, that is n cap. Okay, that is also correct. Now that D part is, at the surface of conductor the electrostatic force must be normal to the surface. That is also 100% correct. So we can say that this C and D part is correct. And what about the E part? The potential is zero. No, potential is not zero. Potential value is same as the on the surface of conductor. That is how much, kq by r, we can say that. Okay, so this is also incorrect. So ACD means option number C is correct here. Now see the point here, in the first option they say that electric field is zero of conductor, that is correct. Now electric field on the surface of conductor is equal to, that is how much, sigma by epsilon, that depend on surface charge density. That is correct. That is correct in this statement, but in the question that is wrong, right? In C option, the interior charge conductor cannot have any excess charge in the static. This is the correct statement here, that is mentioning. These are the actually property of conductor I am mentioning here. So you may write as a notes also. These are the property of conductor. At the surface charge conductor, that is perpendicular to the surface, always the electric, we can say that electric field lines passing perpendicular to the surface on the conductor part. Okay, now when we going to the next question, see this question is related to electric dipole. First of all, I am giving you the basic idea about dipole. What is dipole? See this. So we are talking about the dipole here. What is dipole? So dipole is the setup of two charges, we can say that, having same magnitude. Okay, and the distance between them is either d, or we can say that 2a, right? These are the dipole. So this, and the dipole direction will be how much, from the negative to positive charge, means that is p to a. Clear to all of you? Okay, now we are discussing about the dipole. Dipole means p is equal to how much, that is q into d, means magnitude of any one of the charges into the distance between them. Okay, and the vector, that is from negative to positive. Already I am saying to, direction is from negative to positive. So dipole is equal to how much, q into d, or we can say that q into 2a. These are the formula of dipole moment, right? Now, what is the torque equation here? That is also very important. Torque equation is equal to, that is P cross E, or we can say that PE sin theta. This is very important formula here. Just remember this formula. Okay, and the potential of dipole is potential energy is equal to how much? That is U is equal to minus P dot E vector, or we can say that is PE cos theta minus P cos theta. Now this formula also used in the further question. So first of all, I am discussing about the previous question. Whenever you discuss this question, then we can say that the dipole moment is given to you. So P is equal to how much? 5 into 10 power minus 6. P is equal to 5 into 10 power minus 6 Coulomb meter is given to you, right? And electric field is also given to you how much? That is 4 into 10 power 5 Newton per Coulomb, right? And the dipole rotating from the 0, that is 60 degree, means theta 1 is equal to how much? Or initial theta is equal to how much? Initial theta we can say that 0 degree, and the final theta is equal to how much? That is final theta is equal to 60 degree, right? Now, so they say that what is the change in potential energy? Okay, they ask you change in potential. What is change in potential? That is U final minus U initial. Okay, this is the formula. So we can say that minus P cos theta final minus of minus P cos theta initial, right? So we can say that here take P common minus P common. So this is cos theta, means cos 60 degrees how much? That is cos 60 is we can put the value here, cos 60 and 0 na. So we can put here, that is initial minus final na. So when I put minus sign here, so we can say that cos theta final, okay, and minus sign is outside, so this become minus only. Okay, this is how much? That is theta initial, right now. So we can say that minus PE cos 60 is equal to how much? That is 1 by 2 and minus 1. So we can say that minus PE into minus 1 by 2. So we can say that half PE. Okay, delta U is equal to how much? Half PE. So I am putting the value here, that is half into 5 into 10 power minus 6 into 4 into 10 power 5. So we are easily getting from here, that is this is 2 10. So we can say that this is how much? 1 joule is the correct answer. Delta U is a 1 joule. So we can say that the option number D is correct here, right? Now, whenever I am going to the next question, the next question is related to the we can say that charges, right? We can say that the related to approximately, we can say that Coulomb's law, right? Type of structure. So first of all, you see that what is Coulomb's law and how it works, right? So the fundamental property of charges the fundamental property, that is quantization of charges, conservation, and like unlike property is there. Among this we are talking about the method of charging the friction method, conduction method, and induction method. So in the case of friction method, when two body are in rough, we rough two bodies, suppose that silk cloth or a ebonite rod, then the charge will be transferred from one body to another body. In this case, we can say that the charge is transferred until the both charges must be same, means till that point the charge is transferred from one body to another body. In second case, conduction method whenever the two body are in contact, when charged body and uncharged body are in contact, then charged body transfer will be transferred to the uncharged body until the both charge are same. And in the case of induction process, the two charged and uncharged body are very near to each other, and the charged body charge will be transferred to the uncharged body until the both charges are same. So these are the basic 3 points we are discussing about here. Now, what is the Coulomb's law? And this is the scalar quantity, vector quantity we are discussing about that. So Coulomb's law says that whenever the two charges are there and the distance between them is r, then the force between them will be how much? That is k q1 q2 by r square, where k is the 1 by 4 pi epsilon, that is permittivity of free space, and the value of this will be how much? 8.85 into 10 power minus 12. That is f by m, right? These are the point. Now the vector form of Coulomb's law is this one. Okay, this is f12 is equal to k q1 q2 by r12 square, where r12 cap, right? R12 means r12 vector is there, right now. This is the formula. Okay, now we are discussing about the question. So what they are saying in the question, they say that two identical charge A and B, and their force between them, charge is q and the force between them is f. Suppose that I am saying to A and B are two charges. Okay, r distance is there, so f is equal to, the charge on this will be qq, so k qq by r square, or we can say that k q square by r square. Okay, now this is the case 1. Case 2 may say that a third charge of uncharged conducting bound contact with A. Okay, whenever the third charge is uncharged of same type of, we can say that A and B, charge is Q and charge is Q, right? So when third charge is coming, when third charge that is uncharged, okay, C point something, coming to B, when they contact with B and this third charge is uncharged here, so in this case the both charge will be in contact, and after contacting both the charges, we can say that they are sharing their charges with equal amount. So this charge become how much? That is Q by 2, and this charge also Q by 2 after contacting, right? So and again then this C point will be transferring to this. So again already here charge is Q, so Q by 2 plus Q by 2, that is how much? 3 by 3Q by 2, right? So 3Q by 2, again they are divided with equally. So the charge Q1 is, we can say that the charge Q1 here is Q by 2 and the charge Q2 is how much? That is 3Q by 4. Okay, and the distance between them is same. So what is the F here? So we can say that F dash is equal to K Q by 2 into 3Q by 4 divided by R square. So we can say that how much? 3 by 8 K Q square by R square. So this value is the initial value, that is F, because option is mentioning you in terms of F only. So this is F. So we can say that F dash is equal to 3 by 8F. Okay, so F dash is equal to 3 by 8F. That is option number B is the correct option of this question, right? Now we are discussing about next question. So in the case of metallic cube, okay, the side of metallic cube will be A is equal to how much? That is 5 into 10 power minus 2. So what is area? Area of cube is how much? The area is equal to 6A square. So we can 6 into 5 into 10 power minus 2 square, right? And the charge will be given to you. The Q is given to how much? That is 6 microcoulomb. The charge is given to 6 microcoulomb. Then surface charge density is. First of all, I am discussing about all the surface charge density formula. Surface charge density will be how much? That is Q by A. Okay. There are three type of surface charge density. First is the aerial surface charge density, right? This one. And this is a linear. Linear mein we are getting the lambda is equal to Q by L. That is length, charge by length. And one is volume. Okay. So aerial is Q by A. First is the aerial. That is linear. This is the first type. This is the second type, and this is the volume is the third type. So volume rho is equal to how much? Q by B. So in this case, right now we are discussing about this, that is aerial charge density. Okay, so in this aerial charge density we are discussing about Q is equal to this value. So whenever I put the value, that is Q by A, then we are getting 6 into 10 power minus 6 divided upon that is how much? We can say that this value become how much? The metal cube, this value, okay, given to you, and the charge density of this will be. So I am putting the value of area, that is 0.015, right? So when I solve this value, we are getting that this one is how much? That is 4 into 10 power minus ka 4 coulomb meter square. So sigma is equal to, we can say that 0.4 into 10 power minus 3 coulomb meter square. Okay, we are getting 0.4 into 10 power minus 3. So 0.4 into 10 power, that is option number D we are getting here. Now a cube size is given to this, charge given, the surface charge density of this will be how much? This one. Okay, we are getting this value. Okay, this is clear to all of you? Now we are getting this. Okay, this is 6 into this value, no? Okay, so 6 cancel out and we are getting this value. Yeah, correct one. So we are getting 0.4 into 10 power 3, right? Now whenever I am going to next question, see this next question is related to the electric potential. First of all, I discuss about what is potential. Potential is equal to nothing but a work done by charge. These are the basic thing, and the formula of this will be how much? That is potential is equal to KQ by R. Okay, so this basic formula you have to know, and the relation between this will be how much? E is equal to how much? The scalar quantity minus del V. Okay, this is the gradient, potential gradient. Okay, this formula you know. So we are discussing the question is very easy, right? Whenever I am discussing the electric potential at a distance of 9, so R is equal to 9 centimeter and charge is given to you, that is how much? 4 into 10 power minus 7 coulomb is given that. So what is potential? That is KQ by R. So we can say that 9 into 10 power 9 into 4 into 10 power minus 7 divided by 0.09. okay, because you must convert into meter this one. Okay, so this will become how much? That is 4 into 10 power 4 volt. So what is the value? Option number D is the correct option according to given question. Okay, now we are going towards next question. Next is the spherical cell and this. So first of all, you know the basic concept of a spherical cell. What is the concept here? So cell having a three part we are talking about. First is the inside the cell. Inside the cell, the electric field is zero, but the potential is not zero. Initially, I talking about this potential is kq by r. Whatever the potential at the outer part that is surface का potential बच्चे, the V surface potential is equal to how much kq by r. Okay, and inside is how much? V inside is equal to how much? That is again same, because potential are not zero but electric field is zero. Why? Because q in is zero. Okay, now in the case of on the spherical, that's the potential is same and the electric field also here E is equal to how much? That is kq by r square on the surface, right? And we can say that the graph of this will be given to you, and in outside it will be how much? That kq by small r at the distance at the point P somewhere, right? Now in the case of this, we can say that V is equal to how much? That is kq by r for small r less than r. Means this is we are talking about either on the surface or inside the surface. So potential at P point, potential at C point and potential at P point are same. That is how much? kq by r. So if they ask you what is the potential difference, है ना, तो potential difference बच्चे in this case will be how much? Zero. Why? Because both the potential are same. So we can say that option is D, or D is the correct option here, right? Now when I discussing about the next question, so in the next question we can say that the potential of the axial point is given to you. So the potential at axial point is on the dipole, that is given to you, that is kp cos theta by r square. We know this formula. Okay, so just I show you the theory part also. So whenever you can see this, this is the formula, right? This is the formula. The formula for the general formula for the V at this point, the formula is how much? kp cos theta by r square. Okay, this formula is important. I am discussing this formula here right now, and the graph of this will be like this way. And the special case में whenever you can say that ना, the part of this is 180 at 180 degree 0 degree पे अगर आप बात करोगे बच्चे, तो we are getting the formula is like this. The same formula is there. Okay, nothing will change here. Now we are discussing the question here. The axial, the formula of this dipole will be this one. So if theta is equal to 0 degree, the formula is equal to how much? That is kp by r square, because cos 0 become 1. So V is equal to how much? Because V is equal to how much? V is equal to, that is 9 into 10 power 9 into 4 into, okay, that is 10 power minus 6 by 4. So we can say that 9 into 10 power, that is 3. So according to given option, this is correct one, right? Whenever they say that mark this is correct, so thus assertion is correct here. Now what about reason? Reason say that the potential is this. तो potential का formula बच्चे ये तो होता ही नहीं पहले. 2p is never in the formula. So this is already wrong, and they say that the dipole, no, this is wrong. Okay, so we can say that option number C is correct. Okay, because according to formula, the formula is this only, not 2p. 2p is never here, right? So we can say that the formula is wrong. Now in the case of next question, we are talking about the Gauss law. So I am discussing here the according to Gauss law, electrostatic, the flux through the closed surface depend on. Actually, the flux through the closed surface depend on what about the charges inside the surface. That is very very important. So the quantity of charge enclose the surface. Actually, this will be explained in Gauss law. We can say phi is equal to q in by epsilon naught is the formula. Okay, so only depends on charge enclosed by surface. So this is the flux. Okay, or we can say that Gauss law is equal to phi, that is E dot ds is equal to, this is the surface area, okay, not displacement, that is qn by epsilon. So in any closed loop, we can say that the charge is total number of charge inside the loop upon epsilon, that is a multiple of 1 by epsilon time of qn, right? So see the Gauss law definition. We are talking about Gauss law definition here. See this Gauss law express you that in an electric flux for the open surface, the flux formula is this one. For closed surface, this is the Gauss law. For closed surface, इसको Gauss law बोलते हैं बच्चे, ठीक है? This is the Gauss law. Okay. Now phi is equal to E enclosed by epsilon. This is the application of Gauss law. So these are the main formula of Gauss law, enclosed by epsilon. Okay. So you just remember the formula and basic things about the Gauss law. Now that question completed, no? That question is completed, right? Previous question, yeah, is completed. Okay. Now I am discussing about the next question. The next question asking in NEET examination, they say that a charge q microcoulomb placed at the center of cube. Okay, center of cube के बीच में है ना, somewhere we can say that we are keeping a charge q. Okay, the flux coming out from the one faces. Okay बच्चे देखो, in this case we can say that flux equal to how much, that is q by epsilon naught according to Gauss law. Okay, but they are coming about the one phase, means how many phases are there. So this is the, we can say that total flux is this formula. So flux by phase equal to F total by 6, means there's a 6 phases in a cube. So we can say that q by 6 epsilon naught is the correct answers. So in this case, okay, that is charge is given to you microcoulomb na. So according to given option, we can say that by phase equal to how much, that is q into 10 power minus 6 by 6 epsilon naught. Okay, these are the correct option. So I think in this case the D option is the more correct than any other question, right? And just go with the theory part of this. See this is the cube. In this cube, if the flux is coming out in the any faces, either up, down, left, right, and a back side or the front side, any of this, then the formula of this will be how much, q by epsilon naught, 6 q by epsilon naught. So see this, when the centroid, the flux formula is this one. When the centroid sphere is given, if it given to you, okay, then q by epsilon naught. When the centroid cylinder is given to you, then these are the formula. Just to remember the formula, this will be help you out when you solve any other question related to this, right? So that's all for today. We are discussing the chapter, like all the important concept here. Okay, and hope so you are doing well in your exam, for preparing well for your examinations. Happy learning to all of you, right? And if you have any doubt regarding this chapter, or if you have any particular doubt in certain chapter, just let me know in the comment section. I will make a video on that part, right? Thank you.